In science, a force is an interaction on an object that causes it to change its motion, which could mean speed up, slow down, change direction, or an interaction that causes an object to change its shape. In Year 7 we usually say that a force is a push, pull, or twist. Although when you look a bit closer you realize that when you're talking about a twist, what you're really talking about is either a push or a pull. So it's also okay to leave out or twist and say that a force is a push or a pull. Forces are all around us and they're acting on us all of the time. If we have a look at this picture of a car, which could be sitting on a road, we probably already know that straight away there's a major force acting on it. That force is pulling the car down, and that force is called gravity. Now if gravity was the only force there, the car would actually start moving downwards, it would start falling. When it's on the road it's not doing that, and the reason is there's another force acting on it. And we actually call that a normal force, and that is the force of the road pushing up on the car. If you don't believe that that force is there, I dare you to put your hand underneath one of the tyres, because if the normal force wasn't there you would not get hurt at all. Now if that car is just standing still, if it's stationary, nothing else would happen and you wouldn't expect anything to happen. If there's a driver in the car, so here's our driver in the car, hands on the steering wheel, the driver pushes the accelerator, the car starts moving forward. The reason it starts moving forward is there's actually a force being applied in the forwards direction, and we call that a driving force. When the car starts gaining some speed, there's also other forces acting on the car. One of them, it's actually a number of forces, are due to friction. That's things like there's friction within the car, the tyres are in contact with the road causing friction, there's particles of air hitting the car that are also causing friction. An easy way to experience that frictional force is if you are in a car and you wind down the window and you stick your hand out the window while it's moving, you can feel the air pushing your hand backwards, and that is due to the force of friction. We can look at another example there if we want to. So here's another example. Ground. On the ground you have a person just standing, not going anywhere, having a good time. And because the ground is part of the earth, we know that this person is going to experience a force downwards, and that is due to gravity. One of the things about living on earth is that gravity is always around us and we basically cannot get away from it. But as I said with the car, if that was the only force, the person would be falling down. So there's probably another force acting up, and that is the force of the ground pushing up, and we call that a normal force. And that is the actual force that means when you stand on your feet you actually feel the ground pushing up on your feet. And if they're the only two forces, you wouldn't expect anything else to happen. If sometime later though that person decides to start running, so they start running in the forwards direction, and you're about to see that I'm very bad at drawing. There's our little man, there's a little nose, some hair, running forwards. Okay, gravity hasn't disappeared, we still have gravity acting on that person. There's still a force actually upwards whenever the person is in contact with the ground. Okay, because when you put your feet on the ground you'll actually feel that force. But now as the person takes every step, there's actually a force going forwards, and we can call that a driving force. And you would know from experience that as you're running you are feeling air particles hitting you, and they all cause friction. and friction is trying to slow you down. Later on we'll look at what happens when the sizes of these forces change.